Okay, good morning or good afternoon. We still have 5 more minutes to go. Hello, uh,
Hello.
Professor Chakraborty.
Yes.
Can you see me?
Good morning. Yeah. So we'll start in 2 minutes, right?
Yeah. We have 2 more minutes and then we can start.
You can listen to me, right? Is am audible?
Yes, you are.
Okay.
Yes, so we have
So
like two more
you'll
minutes, then we can
introduce me,
start.
right?
I think
Or okay.
we were running
Uh,
through the lunch break, lunch and
yeah,
social
yeah,
networking break. I hope people network with each other,
yeah.
add each
I
other on
miss it.
Facebook.
Yeah, I'm missing it. Taiwan, still you have to stay 3 days in hotel, right?
Sorry. Something happened. Yeah, connection problems are very serious these days. Okay, we have 1 minute to go. Afterwards, we can start our afternoon session. Okay, I think it's 1:30 p.m. in Taiwan, and I believe that all of you have either lunch or your breakfast, depending on where you are. So I think people in India, because at the moment in India the time is like 11 a.m. I guess, and I think uh, people there still haven't had their lunch yet. But in Taiwan, time is 1:31 at the moment, and we just finished our lunch. I hope this break was useful for most of you for social networking and your lunch purpose. Okay, so let me quickly share my screen and we can move further into this event. Okay, I think you can see my screen now. Yeah. So I think let me just show you the agenda of this meeting, this event. I think we have successfully completed our first three sessions, like opening remarks, session one and session two, and now uh, we are heading towards session three now. And in session three, we have three activities. So first one will be the keynote speech by Dr. Professor Gautam Chakraborty. Then we'll have industry demo exhibition that will be conducted by Professor Fang. And in the end, we'll have a closing ceremony. So let's go step by step, and let me take the opportunity to quickly introduce you, Dr. Professor Gautam Chakraborty. Dr. Chakraborty is a distinguished professor and currently working as a dean of Global Initiative for Innovation at Madanapalli Institute of Technology and Science, MITS, Andhra Pradesh, India. And today he's going to talk about computer-aided diagnosis, CAD. Let's give him a big hand. And Professor Chakraborty, I request you to share your screen so that we can see your PPT and you can start your presentation. Thank you very much.
Yeah. Could you see my screen? Huh?
Uh, uh,
I
Professor,
have
can you
shared
please share your
my
screen? And
screen. It's okay?
yeah,
Okay. So first of all, I'd like to thank uh, the organizers of ITVTI forum, and especially Professor Chu and William and Miss Alanda. And actually, I feel very sad because I could not be present there. Probably Taiwan is my most visited country after US and Canada. I visited Taiwan, I could not count, maybe 15 times, especially Taichung and a little south of that, uh, Sun Moon Lake and all those areas. I visited many umpteen number of times, and I would like to visit again, but this time I could not. Okay, so my talk is basically a computer-aided diagnosis. Okay, and
I'm sorry.
okay,
Oh, we cannot see your
could you
screen.
listen to me?
Do you have
Or
a
is it?
PPT?
Yeah, I have a PPT, and that is on my screen only.
Okay, maybe you can share your screen. Maybe you can go to Microsoft Teams, and we have a conference
Yeah,
call
I'm in
here.
Microsoft Teams
And
only.
there's a button called
Just a
share
moment.
just next to the leave
Yeah,
meeting
yeah.
button, and you can click there to share your screen.
So now it's okay.
Uh, no, actually,
Open
we
share
see you actually, but we cannot
tray.
see your PPT.
Is it okay now? Just a moment. Yeah. Can you can you can you?
Or maybe I first like stop sharing my screen. Probably that will help you. Um,
This time is it okay?
uh, Actually, we can see you basically. We cannot see the your
What do you
PPT.
mean?
There's a button share just next to the leave
Yeah,
meeting
I
button,
mean,
and click there,
after the
and then
microphone, there
select the
is a
screen you want to share.
share tray, right? After the microphone, camera microphone, there is a share tray.
Yeah, share. Yes.
So now it is in the
Just
share
click
mode.
there and select maybe screen.
The screen. Show meeting details. But I have shared
Okay,
the
or
screen.
you can send your file to me, or like you can share on the chat box, and I just share that.
Yeah, my file
I
is
have.
already there with
So give me
William.
like 1 minute, maybe I open it for you.
Yeah.
Before he send the
We have your file. Let me open that. Thanks, William. Okay. Let me share my screen and maybe.
Okay.
I think you can see that, right?
I cannot see.
Cannot.
Now I can see. Yeah.
Okay. So yeah, you can give presentation and just tell me, and I go to next
Okay.
slide. So.
Okay. So basically, this work is on computer-aided diagnosis, and it's part of smart city. And the second reason I want to present this work is that two of my co-authors, at the end you can see, I mean, I got the data actually from one professor in Chaoyang University, Taichung. And so I want to share this work with you all. Okay, so please go to the next slide. Next slide, please.
Yeah.
Okay, so basically, a smart city is
是
about
这个好像是
collecting,
答辩。
analyzing, and communicating information.
没事哦，你没有看到？
Okay, and with aging society, remote treatment an important component of the smart healthcare. So remote healthcare has some important aspects like you have to, I mean, even if you are not physically present for your, I mean, advice from your healthcare doctor, it should be available through, I mean, remote convey of information and probably a smart algorithm to analyze your problem. So in that way, we can get rid of human interaction as far as possible, and that makes the, I mean, life for all people who cannot move, mobility is less, to have advice in time. Okay. So in a smart city, for a large part of the population and comprehensive and well-formatted medical data is available. That is one of the most important thing. Uh, in uh, in most of the countries, even now, the healthcare data is scattered and not centrally available. So once they're centrally available, that I mean, in a smart city, we plan for that, and then it's possible that we can have more, I mean, knowledge by mining those information. So next slide, please. Next slide, please. Next slide. Hello. Next slide. Yeah. So why two slides are, I mean, jumping two slides at a time? No, no. This we already
Okay,
should.
give me 1 second. I think there's a time delay. So
I think the network is not.
is that correct?
Yeah. So, what are the roles of machine learning in smart healthcare? Okay. Uh, Recently, we have a lot of, I mean, algorithms, especially based on computer-aided uh, diagnosis, where image analysis is much more sophisticated than it was maybe 5-10 years back. So, especially in the area of signal processing, in the area of image analysis, and nowadays most of the, I mean, diagnosis based on images, especially for cancer and all, where you get a, I mean, CAT image, or we get the MRI image and things like that. So if we can analyze those images, we can have better diagnosis for remote places. Okay, so that is one of the, I mean, important aspect, or one of the important area where we can contribute. But there are problems. Basic problem is that because deep learning is a black box, it's difficult for the medical practitioner to believe that, to trust. Okay. And another thing is that uh, I mean, information is diagnosed. That varies from country to country, from city to city, even I've seen from hospital to hospital. Okay. And that's why in medical image analysis and medical uh, diagnosis algorithms, we say in sample and out sample. In sample means all the samples collected from a particular hospital. Out sample means information from outside that particular hospital. It appears that if you analyze, I mean, you do the training, validation, and testing, all those sets, but all those data is available only from a particular hospital, and that gives very good result. But if you try on a data which is collected from another hospital, sometimes the result is poor. Okay, so it's very important to have information from all the hospitals, or maybe from all the cities, in a centralized location, and do the training. I mean, uh, training your artificial intelligence algorithms based on the whole set of data, where the generalization will be much better. Okay, but these are the issues which we can solve, or which we can sort of achieve only when we have smart cities. So that's one thing we should go for. Next slide, please. Next slide, please. Yeah. This particular example is based on diagnosis of liver cancer. But as you know, probably, that cancer is of various types. Breast cancer doesn't mean a particular type of cancer. There are various types of breast cancer, various types of cancer, pancreas cancer. All, I mean, in every cancer, even at a particular body part, it could be of different type, and having, I mean, identifying the particular type of cancer, uh, it improves the prognosis. But for liver cancer, 75, in fact, more than 75% of the liver cancer, and actually it is sort of dependent on different countries. It is called HCC, hepatocellular carcinoma. And this work is based on how to diagnose HCC type of liver cancer. Okay. So I mean, it's restricted, but if you go through all these slides, you'll understand that the ideas we presented here could be used in many other image, cancer image analysis. Okay. Here I would like to emphasize another thing, which is for, I mean, all the time the biomedical engineers, they're trying to find a way to collect the data without any physical intervention. And for cancer detection, they have proposed ultrasound, nuclear magnetic resonance imaging, and all. But pathological test is the gold standard. I mean, because you can see in your own eye uh, the stage of the cells and cytoplasm. So that is the gold standard. So finally, if through image, it seems that your chance of cancer is high, for final decision, you have to take the biopsy. It's true for liver, it's true for lung, and for all the cancers. Okay, next slide, please. Basically, next slide, please. Basically, for liver cancer, we have 5 stages. Stage 0 is healthy, and stage 1 to 4 is, I mean, morbidity is worse. 1 is more or less okay. Initial stage 2 is also more or less okay. But 3, 4 means it's quite, I mean, advanced stage, and it's going to be metastasis. Okay. So for the, I mean, we can, some people divide in 3 stages, like healthy, initial stage, and fine, I mean, a bad stage. So 1 and 2, it's initial stage. And 1 and 2, the treatment regime, and 3 and 4 stage, the treatment regime are completely different. Because if some patient is in initial stage and it is given, he or she is given I mean, later stage treatment, which is very, what I should say, like chemotherapy and all, which damages the healthy cell as well. That's not good. But on the other hand, if the stage is late and you treat like an initial stage patient, that's also will not work, and the patient will have metastasis quickly. So, I mean, grading of the cancer is very important. Okay, so correctly grading of the cancer is important, and in this work we show that we are the first to grade the different stages starting from 0 to 4 with a very high accuracy. In fact, almost 100%. Okay, so basically today's agenda is we'll introduce a little about HCC, and we'll talk a little about previous approaches, and we'll tell what are the, I mean, novelty of our proposal, the new thing, and we give some experimental result and future extension. In the future extension also it's important because we try to expose some of the intermediate results of our algorithm so that we can convince the doctors that the way we are deciding is more relevant or more conforming to the way actual medical practitioners take their decision. In that way only we can convince the doctors, and I think that's important for any research on, I mean, computer-aided diagnosis and related works. Okay, next slide, please.
Yeah.
Okay. So here you see the different 5 grades, grade 0 to grade 4. The picture is small, so I don't know whether you could, I mean, make the difference clearly. If it is grade 0 or healthy, the nucleus, okay, cell is is the cytoplasm. Inside the cell, there is a cytoplasm fluid, and then inside that, the nucleus. The shape and the texture and the boundary and the size of the nucleus is the main thing by which the doctors take the decision. Okay. And like if the nucleus is quite large, then probably it's cancer. If the nucleus boundary is not, smooth, probably it's cancer. Or if the nucleus is spherical, it is healthy. But as the stage of the cancer is a latter stage, then the shape of the boundary becomes rugged. Ups and downs and like that. Okay. And not only that, there are other features like the ratio between the cytoplasm and the, cell side and the nucleus. Basically, if it is cancer, the ratio of cell size, nucleus size by cell size, they used to become more and more. Okay. I don't know, but probably I have listed some of the features that the doctors look for. Basically, there are 7, 8 features that the doctors always look for to decide whether it's a cancer or not. And we call it a morphological feature. But as you know, if you use deep neural network for extracting features, we really don't have any handle. We really don't know what are the features being extracted. And not only that, in all the previous work, the researchers, they try to segment the nucleus only, and from the nucleus they take the decision. But in reality, the doctors, they also see the texture of the biopsy image. So in this work only, for the first time, we added the texture feature of the biopsy image as well as the nucleus feature. And then we we use two different, parallel deep learning, convolution neural network to extract the features from the texture as well as to extract features from the nucleus. And then we concatenate all those features, and then we have the full connection or classifier. So if you do that, we get much better result. And we did 2 experiments separately. One just collecting the features of the nucleus and see how much is the accuracy, as was done by others. Even recent works. But when we add the texture feature, we call it experiment 2, we can achieve much better result. Next slide, please.
Yeah.
So these are the features the doctors look for: nucleus size, boundary irregularity, chromatism is color, nucleus texture, nucleus cytoplasm ratio. That ratio grows as it is more and more. And the last one I could not see, probably it's sphericity. If it is sphere, it's good. If it is not sphere, in Japanese we call dekoboko, then it is bad. No. Then next slide, please.
Yeah.
Next slide, please. Yeah. So in all the previous work, what they did is that they segment, they sort of took different parts of the image, and then nuclei is segmented. So just took the nuclei part, feature extracted, and then some classified and take the result. But what we did is that, basically same, but we did 2, 3 important tricks that I'll tell you. First of all, when we segment the nucleus out, there are some other elements like red blood corpuscle and all. They also are sort of segmented out, but they're not nucleus. So if you use them in our sort of extracting nucleus feature, then we had some other features which are not really nucleus feature because they are non-nucleus elements. So we, for the first time, we gave an algorithm to separate out all those, nucleus-like elements from our nucleus set, and then only use them as the input to the classifier. So in that way, we sort of eliminated some noise, And then secondly, we added the texture feature. And if you do that, I mean, by doing that, so two important sort of novelty in this work is how to eliminate those nucleus-like, I mean, uh, nucleus-like things which are segmented out, but which are not actually nucleus. How we separate or filter them out. That is one contribution. And the second contribution is, of course, easy. We take a part of the texture feature. For extracting the texture feature, another good thing we did is that in the texture, we just, I mean, took out the nucleus things. Nucleus itself is a very complex structure, so that gives sort of complexity. But when we whiten that portion where actually there was a nucleus, what we have is just the texture of the biopsy image, and the portion where the nucleus was is just whitened. But that carries the periphery, the boundary feature of the nucleus and the size of the nucleus, those features which are actually a feature of the, I mean, of the biopsy image and used for decision, that is kept. Okay, so in that way, we make the texture features simple, but at the same time retaining all the important features uh, that should be used for classification. Okay, next slide, please.
Yeah.
So here we'll show that, I mean, the difficulty of uh, extracting or segmenting the nucleus. So nucleus, sometimes the boundary is very blurred. And as you see from grade 0 to grade 4, uh, I mean, yeah, as you see from grade 0, if you see the bottom row, you can see for a healthy nucleus, it's almost circular. And if it is grade 4, the shape is very bad. And there are some images which are very clear, but some images which are quite blurred. So segmentation itself is difficult, but I don't want to spend much time on that. Next slide, please. I think we can. Here we just say that Edmondson and Steiner criteria includes nucleus feature as well as the biopsy, I mean, biopsy image texture feature. Okay, next slide, please. And to use the biopsy image texture feature is not our idea. It's an old way the doctors used to diagnose, but nobody who worked in the computer diagnosis area, they use that. So we use that and we got a good result. So here you see that if we use that on the right hand side, oh no, these are, I think, some others work. Okay, next slide, please. Next slide, please. So this is the whole, I mean, algorithm flowchart. We first did nucleus segmentation, then we filter out those which are nucleus, but other things which are not nucleus, we filter out. That is, so second is a very good, I mean, contribution of this work. The nucleus classification we did using deep learning. Actually, before us, most of the people use CGC and all, but we use ResNet and DenseNet, and that's why the result is a little better. But our main contribution is two. And then classification, we use DenseNet. That is not our contribution, but somehow the previous source they didn't use DenseNet. DenseNet gives better result. Okay, so next slide, please. Here, segmentation, I don't want to elaborate that. Next slide, please. So here you see, I mean, we take out the segmented parts. So on the right, you can see the nucleus. And in the middle, black and white dots, the white dots are the nucleus part, which is whitened. So this image we use for, I mean, biopsy texture feature. Okay, next slide, please. It's okay. Next slide, please. So here we showed how we filtered out all the one, two, three, four, five, six different pictures. They are not nucleus. The first one in nucleus, but two nucleus are overlapped. Naturally, the shape and the features are different. And then there are other, things which are in the biopsy image, but uh, not nucleus. They are also included. Our aim is to filter them out. How we did it, the detail is a little difficult. We do clustering and things like that. But let us omit that and go to the next slide. So this is how we did the clustering. Actually, we took the features and we don't train the DenseNet to the, to 100% accuracy, but we stop. But those things are a little complicated. Let us go to the next slide. And yeah, here we show that by doing 95% of the training, we have the features, but that is not overtrained, and those features are used for clustering. And then, on the periphery of the cluster, those noisy images are there. So the periphery things we deleted, and we could get the nucleus image only. So that's a, filtering. Next slide, please. So this is the whole picture of our system, and this is important. So we take a nucleus and put in this top row, deep neural learning thing. So this is a DenseNet, and we take the features of the nucleus, and here we get the features. We go to the bottom row, what happens is that we whiten the nucleus portion, and then we take a, random patch from the biopsy image. And then because the biopsy image is not so complicated, we use a smaller DenseNet. You see above, we have more filters and all, below we have less filters. And then all the features extracted by the top row and bottom row are concatenated, and this is a full connection classifier. And finally, we classify. So this is how we train, and this is how we classify. Okay, next slide, please. Next slide. Next slide, please.
Final decision.
Yeah, so final decision, you can go, actually final decision, this is a biopsy image. We take nucleus image, and then we take random patch image, and then combine them, and finally. So in the final decision, so this, for example, this biopsy image has a total of 150 or 200 nucleus. So all the nucleuses are graded, but then you see, if you grade all the nucleus, some will be grade 0, some will be grade 1, some will be grade 2, some will be grade 3, some will be grade 4. So you see which one is highest. For this biopsy image, the highest is grade 4, 137. The others, and actually grade 3 is very near, so you have some. But others are almost 0. Okay, then final decision for the biopsy image that it is grade 4. Okay, next slide. And these are the results. So if you use only the nucleus image, not biopsy image, our accuracy is 94% for nucleus classification. Next slide, please. I could not see the final result, but anyway, I think it is 99, 90, something like 99%. If you see, if you add the biopsy and textured image, then the accuracy is much better. Next slide, please. Yeah, so we already skip it, please. Next slide. So if we don't use the biopsy image, biopsy feature image, then this is the classification. Uh, this is the confusion matrix for the classification. where you can see for grade 2, three grade 2 slides are misclassified. So two misclassified to grade 3 and one misclassified to grade 4. Okay, next slide, please. Where it will show that if we use a biopsy image feature, then only we have one misclassification. So out of total, I think 296 images, only one is misclassified. So the accuracy is 295 by 296, which is quite high, 99.67. Next slide, please. So this is the overall comparison, and there are two different types of results. One is nucleus image classification, and one is biopsy image classification. Of course, biopsy image classification is more important. And then some people do only 2+ classification, 2+ classification, cancer, no cancer. Some people did 3+ classification, no cancer, low risk cancer, high risk cancer, but we did all 5+ classification. And if you see the result, we got the highest result, 99% accuracy. And AUC is 0.9997, which is quite high. If you go to the grading of the biopsy image, there still, we have the highest result. All did 5+ classification, but the previous one got 94-95%, but we got 99.66%. The next slide, please. Next slide, please. Yeah, so this is the conclusion. First of all, if you can get a very high grade of accuracy, only if you can get a very high grade of accuracy, and that too, deciding actual what grade of cancer is this, only then you can convince people or convince a medical practitioner to, trust it. This is first. And second is, if you can give them a method which they do in their practice, then only they could trust. And thirdly, the doctors look for some features. And if you use a deep neural network like DenseNet for feature extraction, you really have no control what features are extracted. So that also is a difficult situation to get the trust of the doctor. So what we are trying to do is that at the end of the feature extraction, actually we extracted 64 plus 64, 128 features. Some combination of them should give the same features as the doctors are looking for. So we are working on that. And another thing is what? Another thing, of course, we use a texture feature which nobody used before. That also will convince the doctors that we are trying to do something similar to how they take the decision. Okay. So with that, I want to conclude. I'm very sorry. We lost some time in the beginning. So if you have any question or comment, I'll be very happy to take. And then we publish this work in IEEE transaction on biomedical and health informatics. I send the paper copy to William, so you can share the paper with anyone who is interested in that area. And if you mail me, my email address is there. If you mail me, I'll be happy to discuss with you. Thank you.
Okay, thank you. Thank you, Professor Chakraborty, for your wonderful presentation. Let me see if I have any questions. Okay, I think we have a couple of questions here. So let me first, read first. Let me read the first question. Are those smart technologies ready already for implementation? What might be the technological infrastructure required for implementation?
Actually, the biopsy image, a common biopsy image, okay? And the algorithm, and actually our algorithm is available on the GitHub. In the paper, you can see the location. So from the GitHub, you can download the algorithm, and if you have any liver biopsy image data, yeah, you can verify how it is working. So everything is, I mean, ready. Just download the program from GitHub, and you need a GPU machine to run that. And then if you have any some oncologist who works with liver cancer and all, and you get hold of some data, you can just run it and check whether the doctor's decision and the decision by our algorithm is same or not.
Okay. Thank you very much for your response. I have one more question in here in the chat box. Let me read that for you. Uh, in case of health diagnostic system, in case a health diagnostic system is interfered with AI, is it possible AI to replace human-based diagnostics?
Yeah, I mean, if you see, uh, for a human doctor, there are some situations like he's very tired, or you are in a city where you don't really have a real expert. Actually, we have seen that in many occasions, if the doctor is not experienced enough, he takes wrong decision, which is quite bad for the patient. And if we show that our algorithm gives a very high accuracy, and if you show that the algorithm actually tries to conform to the decision process taken by doctors, then I think we can, I mean, we'll be able to convince that the most important, I mean, problem I faced is that in our university, actually I was in Japan for last 33 years. In our university in Japan, we didn't have a medical, I mean, university. It's very difficult to, I mean, collaborate with some medical doctor if you don't have a medical university within your own university. If you go outside, and they don't believe you are trusting. So if you collaborate with a medical doctor, and actually this data is not from Japan, this data is from a hospital in Taichung. Okay. If you can collaborate with a doctor, and then only you can listen to what are the things they demand, they like to have, and then only you can convince them. Otherwise, without direct collaboration, it's very difficult to convince a medical doctor, because basically they don't trust you, and for good reasons. I mean,
Thank you very much for your response. Is anybody having any question? Please post in the chat box. But I think we don't have any questions. But in case if anyone have, please feel free to do so.
yeah, you can mail me. In
If no
case you have
questions,
any
we can
question
go for
later,
a group
you can
photo
mail
now.
me. Yeah.
And I think my colleague Stephen Su will help us with
And
that.
most
Please
probably
turn on your
next
camera.
year.
Let me take off my mask. My camera is on. Oh, sorry, my camera's off. Sorry. So please turn on your cameras, and we can take a wonderful, happy picture as a memory of this event.
Okay. Thank you very much. And most probably next year I'll be visiting, Taichung. Hope we can meet personally.
We have over 80 participants in this event at the moment. I hope uh, they enjoyed our sessions. Done. Okay, thank you. Well, thank you, Stephen, for the pictures. So let me again share my, oh, okay, sorry, my screen was shared, sorry. So let me go to my PPT so that I can move on to the next event, next activity. Okay, so before doing that, let me just go to the, yeah. So this is one. Okay, so yeah, so now this is time for industry demo, and I think uh, Professor Bernard Fang will continue with this event. So let me reintroduce him. I think some of you were not there in our morning session, so let me quickly reintroduce Professor Dr. Bernard Fang. So Dr. Bernard Fang is professor at the Department of Computer Science and Information Engineering, Providence University. He got his PhD from University of New South Wales, and I think he will be taking over this session. Okay, so please give him a big hand. Thank you very much.
So thank you for the introduction. And I actually asked to hijack this session. The main reason is because conferences are here for us to establish collaboration links. So I believe the most important takeaway would be possibilities of establishing collaborative research. For that reason, I am taking over this. And first of all, please let me try to share my slides. Let's see if I can do this. Oh, sorry, I'm trying to get myself back because just now, for some reason, my Teams was minimized while I was trying to share my slides. So sorry about that. And let me try this again. PowerPoint Live, I guess I can try. Because just now I was trying to select a window from my desktop and it doesn't work. It looks like PowerPoint Live is not responding at all. So let me try again and see if I could get some better luck with my, no, it looks like Windows doesn't work because it just keeps on minimizing itself. Sorry about that. So let me try again. Hopefully I can get this PowerPoint Live, but
Today we are.
Oh, do I need permission to do that?
Like from today morning, we are experiencing some technical glitches. So I think this is one
Keeps
of them.
keeps doing this, just minimizing itself. Is it showing up? Oh, great, great, thanks. Okay, so looks like I can start now. So I'm here because I actually took over this managing editor role of the ITVTIP Smart Cities newsletter earlier this year. So I was actually selected for this job because 10 years ago I did almost the same thing by transforming the ITVTIP consumer electronics newsletter into the now ITVTIP Consumer Electronics magazine. So that is now a reasonably good journal being ranked at SCIQ1. So actually I am having this task to try and replicate what I did a decade ago with this ITVTIP Smart Cities newsletter. So this, I believe, would be an excellent platform for us to start with some collaboration. Like I would encourage as many of you as possible to consider either running a special issue of your own or at least submit your paper to us. And I'm going to talk about smart mobility for this session. The reason why I choose this area is because it sounds strange to me that we haven't actually had a special issue on transportation, given that it's actually a very important topic in smart cities. So for 2022, we had several special issues on smart grid, smart energy. We did have one on electric vehicle charging. We had some on communications, healthcare, and also standards. But strangely, nothing on smart transportation. So that is the main reason why I suddenly thought this is the topic that I would like to talk about. So hopefully we can generate some research interest, and perhaps someone might want to run a special issue for us. So smart cities, first of all, there are standards. I'm not going into the details because I'm sure I'm sure many of you are going to fall asleep if I'm going to talk about standards, because these are the kind of things that I keep telling students. I keep telling my students that in most cases, if we want to look for details associated with a particular standards, they're always online. So I'm not going to talk about specific standards, but I think it's still an important topic to briefly touch on, because for most system designs, we still have to ensure that we are fully compliant with whatever applicable standards. Obviously, there are several important aspects, like, for example, to ensure interoperability and to assure smooth integration, as well as for ease of management. So there are several important aspects that prompts us into ensuring that we are fully compliant with any relevant standards. So back to smart mobility. In fact, this idea isn't new at all, but only becoming a very important topic over the past few years. One important driving force was the EU initiative of introducing eCall, which is actually a very important system to ensure that in the event of a vehicle collision, someone is going to know about it and also have the exact location of the accident scene being sent for emergency response. So this eCall initiative is actually a very important starting point. In fact, nowadays, most vehicles or most new vehicles in the in Europe should have this eCall incorporated. Something similar with the United States, that have a vehicle-to-vehicle link for accident detection and also response. So there are some important things that actually link smart emergency response to that. Of course, can also be considered as part of the broader smart health scope, where we actually have had a few experts in smart health that have let us learn a lot about the latest development. So this is actually something related. And the next important thing, of course, is the communications technology aspects. So starting from 5G, when the carrier frequency of our cellular networks go way beyond what we were using in the 3G, 4G era, we were kind of like limited to around something like 2.6 gigahertz, for instance, for 4G. In 5G, we can go in excess of 20 gigahertz, and that, of course, would mean that we are going into microcells. And of course, the main problem associated with using such a high carrier frequency is that there's going to be a substantial impact on the propagating wave due to rainfall. And this is particularly important in smart transportation, given the fact that most, perhaps not most, but many accidents are either directly or indirectly caused by heavy rainfall, meaning that in many cases, we tend to see more road accidents during heavy rainfalls. So this is particularly problematic when wireless communications link degrade more under the influence of heavy rain. So this is actually a very important topic to address in terms of ensuring that any communication networks within a smart city infrastructure to support accident response can still operate reliably even under heavy rain. So that's something that I think I won't go into the details because I can easily talk about this for a couple of hours. By the way, my PhD was actually mainly on this area when I was doing some work on telemedicine network reliability. So I think I'll leave this topic for now, but I hope that its importance is now being known to everyone. So one important thing about smart city systems is to generate revenue. That's obvious because if we are trying to collaborate with industry partners, let's say, for example, if we want to roll out just any smart transportation system, our industry partners will almost certainly ask a question about how much profit they're expected to be able to generate. So it's the kind of business world that if we are trying to do some applied research for the betterment of smart cities residents, then we have to make sure that our industry partners are able to generate some profits. So that's something that we need to look at in the design and implementation of just about any systems when we are doing it with industry partners. So business opportunities is actually a important topic. So as usual, there are going to be compromises. Like generally speaking, we cannot reasonably expect a perfect solution that fits all. So it's always about balancing between various different things. So with regard to smart mobility, where we try to get people moving as quickly as possible, as safely as possible, and as energy efficiently as possible. So we are basically talking about trading off between convenience, efficiency, reliability, and also to minimize the environmental impact. And of course, anything to do with smart mobility would involve end users like smart cities residents, as well as visitors that go into the smart city proximity for maybe a few days. And of course, the authority that manages infrastructure and also various other things. So we have to ensure that rolling out any smart mobility solutions would make everyone happy. So interoperability, I think I briefly mentioned this word when we commenced a short while ago, and this is actually very important in smart city systems. Like this morning when I started the panel discussion, I already mentioned that in the case of a smart city, very often we are talking about putting something new into some existing infrastructures. So for that reason, we must ensure that, well, first of all, when we add the new features, everything is going to work. And of course, the second and very important thing is that by introducing something new, we are not going to screw up anything that has been up and running very well in the existing infrastructure. So we have to ensure that everything can work together. And for different entities, they have different expectations and different aims. So basically for government authorities and agencies, they want to make sure that things are going smoothly and no troubles being caused, that kind of things. And of course, for them, one important thing is to monitor road usage as well as congestion. So for service providers and businesses, obviously return of investment is the single most important thing. Utilization, another very important thing. No point in implementing something that is not being utilized, like something that is being redundant for most of the time, and it's not going to be very cost effective at all. And of course, one other thing is that we are always dealing with data or information. So from whatever we collect, like just now I briefly mentioned traffic congestion. So for businesses, like perhaps I would use the Google Map example here, just kind of to illustrate how we can benefit everyone. So as we've probably seen on Google Map, they tend to feature those places where they have placed an ad with Google. So it would make logical sense to Google Map to try and get you into one of those businesses that have paid them for the advertisement. So in a smart cities, smart mobility context, actually something similar could be the case. Like just now when I mentioned traffic congestion, one would be to reroute traffic so that first of all, we can ease congestion. And second, of course, that could possibly generate business opportunities. Like one example would be, if I go through my normal route where I'm expecting a 30 minutes delay. So I'm expecting to be stuck in the traffic for an additional 30 minutes. It would actually make good sense if I could be diverted to another route without traffic jam. And instead, I could perhaps divert myself to maybe a coffee shop where I could enjoy coffee instead of being stuck in the traffic. And of course, that would generate some profit for the coffee shop. So it's this kind of idea that we could make things more efficient while people are happy to spend. So it's just one basic example to illustrate how we can use data to benefit different parties. And of course, for the end users, no matter whether they are residents that live within a smart city or outside visitors, they need updated information. So like if we are driving across somewhere and there's suddenly an accident in front, we would like to know as soon as possible so that we could possibly avoid that. So it's this kind of information update that can make a big difference. And of course, in order to make things work, it's all about properly managing the network. So this network, actually, it refers to both the road network as well as the underlying communication network, simply because we need the underlying communication network to convey the data being collected so that appropriate decisions can be made. So for planning, there are actually many things. So here's just a few examples, and I would just pick security and traffic control for a brief rundown. So security is getting increasingly important because vehicles are now getting connected. So imagine this a situation when someone carries out an attack simply by hacking into an autonomous vehicle. That itself could cause very substantial damage and could and could pose substantial safety risk. So security is becoming an increasingly important topic as vehicles get connected. So traffic control, this could be like congestion. And one other very important aspect about, well, actually, I would like to talk about two important aspects about smart mobility. Is first, to try and minimize the traveling time for ambulances. This has historically been a nightmare in metropolitan cities, where certain roads are completely jammed and ambulance just cannot get through. So with some careful control of traffic flow, we can actually time traffic lights dynamically to let ambulance go through more quickly. So that saves life. That's one important thing. Second thing concerns suburban areas in particular, where residents usually live kind of like less denser than those in city centers. So in order for them to commute, it is often difficult to access public transport due to the spread of people across a relatively vast area. So this is where micro mobility comes in. So micro mobility blends with smart mobility, with little vehicles to concentrate commuters from their home to a public transport hub. So that's another major topic in traffic control, to make moving people more efficient, both in terms of time and energy consumption. And of course, again, by doing this, we can potentially generate some business opportunities. And of course, another important thing is to try and increase the utilization efficiency of things like public transport facilities. So having talked about those important aspects associated with smart mobility in smart cities, next I would like to take a brief look at data analytics. Like earlier, we mentioned that for a smart city to run efficiently, we need the data and the information and also the ability to convey such information. So after that, obviously, we need to make good use of the data. First of all, we need a scalable network. Reason being, we have no idea about what kind of growth we are expecting. Like if we make our smart cities so efficient that people from outside want to move in, then obviously that's going to pose tremendous pressure on our existing road networks. So we have to ensure that our network can be scaled up to cater for the increasing needs. And one other important thing is fault tolerance, because we cannot expect networks to be 100% reliable and available all the time. So should a failure occurs, we should have some kind of redundancies to ensure that services are still available. And one other important thing is, again, generating profit. So that has to do with using business intelligence. It's kind of like finding out the pattern of how people move around the city area, and try and like there's so many things that we could do with these situations. Like just for instance, one of the many examples, when we know that a particular resident travels around this locality, we could offer them some incentives to stay for a little longer. Like, for example, giving them some promotional coupons. If we know their behavior, like if I drive and I very often buy myself a coffee while I pump up my car's fuel tank. With this kind of information known, then obviously it would be logical for businesses to offer me some kind of coupons related to coffee discount. So it's this kind of behavior that we could utilize in order the data associated with this kind of behavior that we could use to increase profitability. And of course, there are other things like monitoring the vehicle's own health, not the drivers, but the vehicle's health. Like, for example, carrying out preventive maintenance, or in the case of electric vehicles where they're getting increasingly more popular, they could have the dying battery cells being replaced before they actually fail. So it's this kind of monitoring that we could possibly do, and of course that would also generate profit for vehicle maintenance centers. Okay, just now we talked about traffic flow. So what makes it important? Just now I mentioned the idea of getting ambulances through in the shortest time possible to save life. So that has a lot to do with optimizing traffic flow. And in theory, we could do some pronostics-based charging scheme for road usage, meaning that we could predict the usage of certain stretches of the road. Like, for example, getting in and out of CBD. We know that during every Monday to Friday morning, going into the CBD is going to be problematic. And likewise, during early evenings, getting out of CBD is going to be problematic. So this is this kind of traffic flow pattern that we could use for road usage building purpose. Okay, so next, a little more about business intelligence. So it's the basic idea of trying to collect usage data to generate profit. And that again goes back to our fundamental vehicular communication network kind of stuff, where a lot of data is actually collected through these vehicular networks. So this one here, the main idea is, first of all, to try and generate profit, and of course also to save time for users. Here's a quick case study, just taking a quick look at how everyone benefits from even something simple like this OBD, this onboard diagnostics of a vehicle. So this, in brief, is a little system that the vehicle monitors itself. Like, for example, if a light bulb fails, that could be an important issue. If a brake light, for example. So it's this kind of things, like if the brake light fails, a warning will be issued to the driver to have it replaced at the earliest opportunity. So it's this kind of thing that the OBD does. And of course, it benefits all parties, like authorities, with things like emergency response. They could control the traffic flow. And to drivers, there are a lot to do with drivers, actually. So earlier, I mentioned an example of trying to generate some revenues from driver. This is only a small part of how we could do something useful with data gathered from drivers. Another important topic that actually we should do more research on is for the health of occupational drivers. Like, for example, truck drivers, bus drivers, all those kind of people. Sometimes they, well, actually for a lot of time, they sit in the driver's seat for many hours continuously. And the combination of things like stress, lack of exercise, all these kind of things can severely affect their health. So it's actually very important to ensure that they maintain healthy. That's the very first thing. And the second thing is, if something happens to them, like for example, if they faint behind the wheel, that could be a disaster. So we have to have some kind of mechanism to detect any health problems with those occupational drivers, so that they can be warned of those problems before they actually pass out behind the wheel. So that would make everyone on the road safer. For service centers, obviously they can generate more profit by attracting customers into them. And one other important application is fleet management. How, for example, buses can be run more efficiently, use less fuel, pick up more passengers. All these kinds of arrangements can be made possible by using the appropriate data being collected. And one final and to me, I believe is the most important thing is emergency rescue. So letting ambulance through efficiently is one of the many applications. Of course, there are other examples like being able to pinpoint and to detect an accident, like when we talked about the e-call system being introduced in the European Union, all that kind of things. Important aspects of smart mobility concerning emergency rescue. So there are other things like parking management, congestion management, etc. And EV charging, I think I want to skip because, as I said, earlier this year, we already have had a special issue being run in the ITVTIP Smart Cities newsletter. So I think because of those papers being featured recently, I think I won't talk about that. So here is a case study from Australia. So safety hazards related to things like fatigue, especially when drivers are on the road for many hours continuously. And well, drink driving and also the abuse of drug, of course, is a very significant safety issue that many countries faced. In fact, I'm very surprised to find after coming to this country that actually there are many people who drink and drive. So it's this kind of health issues that we can easily do to integrate some kind of safety features in smart mobility. Like, for example, something has already been done on vehicles where the driver must pass a alcohol test before the engine can be ignited. So it's this kind of easy safety feature that can be incorporated. So for that to be made effective, we need to collect the appropriate data. And just a quick summary, like I said, I hijacked this particular session because I would like to promote research collaboration. And I believe this IEEE Smart Cities newsletter is a very good platform where we can work together, like running special issues or just by contributing a paper of yours. So this smart mobility actually entails a lot of different research areas. So from assistive technology to communications, IoT, all these kinds of things, and even business intelligence. So there are heaps of collaborative research that we can explore. So that's all from me today, and thank you. I hope that we can collaborate in the foreseeable future. So if anyone of you are interested in running a special issue in the IEEE Smart Cities newsletter, please feel free to let me know, and we can work things out from there. So thank you, and have a good afternoon.
Okay, so thank you very much, Dr. Fang, for your presentation, and
Thank you.
I personally learned a lot from your presentation, I think. So, but let me see if there are any questions. I think at the moment there are not many questions from the audience. I just have one question, because sometimes like I think you addressed a very important topic of like traffic and how to you kind of proposed a few solutions on that. But like in like especially in developing countries, we have this kind of problem because sometimes employment push people to migrate to big cities, and in small area lots of people end up like people stay in a small area. So population density in one of the cities becomes very high, and in that situation sometimes it's very difficult to uh, like manage even daily traffic without any accidents or without any problems actually. So how what I think is like sometimes um, maybe town planning could be one of the important steps we may have to go for. And I think governments or like city governments should play a very important role. Unless their mindsets change, it is very difficult to implement smart city. And sorry, my camera was off. I'm sorry.
Yes,
So
definitely. Sorry.
yeah.
Yes, definitely. And you've brought out a very good point. So you are absolutely correct. There are actually two important problems to be solved. So first of all, for those who are in the rural area, so not many people left, but they still need to be supported. I mean, we don't want to leave them unattended.
Yes.
So it's going to be prohibitively expensive to serve these people, with not many people, but covering a vast area. So that is one big problem. Second big problem is more people go into the smart city proximity, then that is going to pose tremendous challenge to supporting more people in perhaps a fairly short period of time. So that's how scalability kicks in. We need to make sure that our networks and also the supporting infrastructure is scalable to cope for the anticipated growth. So these are problems that we have to search. We have to search for solutions. Thank you.
Okay.
Yeah, I had the question.
Thank you very much for your response. Any other questions from anybody?
I had the question. Yeah.
Yes, please.
Okay, please go
Oh,
on.
yeah, thank you, Dr. Fang, for your presentation. I think it's also
Cannot hear
very
you.
interesting. Can you hear me? Hello?
Yeah.
Yes, I can. Yes, very well.
Yeah, go on.
Okay, so yeah, so actually I think it's a very interesting topic, and you also mentioned about special issue about the smart city. I think very nice. And okay, so I have the many connection with the professor like the C.K. To. You heard about that. He also have the. I'm not sure about his in your university or not, but I think if we have the many good professor and we can make a good special issue for the smart city.
That would be great.
So yeah, okay. The first thing, and the second one should be right now the vehicle ad hoc network also deploys it like demonstration or POC project, and I don't see in the real test bed about the vehicle ad hoc network. So do you have any framework or in any case study for deploy successful of the smart city with the vehicle ad hoc network? so that it can
Well,
can build a good infrastructure for collect information from the traffic or the car also.
yes, actually, this V2V this V2V multi-hop network. Yesterday night, I worked until around 11 and I got up around 4 a.m. this morning because I'm actually rushing through a paper on this particular topic, which is intended to be submitted to a special issue in the ITVTIP transactions on intelligent transportation systems. So actually, this is exactly the topic that I'm writing right now. Yes, because the main problem is especially in suburban areas where
Yeah.
certain people happen to be out of cellular coverage.
Yeah.
If something happens in those areas, someone could be in deep trouble. So
Yeah.
that's why it's actually very important to help those vehicles that are out of cellular coverage still to be able to communicate.
Yeah.
And that's where vehicle-to-vehicle communication kicks in, because there are bound to be some nearby vehicles that are within coverage.
Yeah.
Yes, so actually that is exactly something that I'm doing right now. And of course, if there are there are collaboration opportunities, I would be more than happy to discuss with you.
Yeah. Yeah. Okay, so I think the good chance for our collaboration. Thank you.
Yes, yes, definitely.
Is off now. Okay, thank you both of you for this session. And so now I think let me again like quickly share my screen.
So we definitely keep in touch, by the way.
Okay, so we contact by email. So I send my email in here, so
Okay, so
so
I
that
think
we can contact together.
we
Thank
are
you.
already in the session 3 and we have completed first 2 activities, and now we are going towards our closing ceremony. So let me request Professor Fang again for giving closing remarks.
Well, actually sounds to me that I've just closed the event because it sounds to me that we have really achieved what I wanted originally. That is to establish research collaboration ties. So I'm very happy to have this kind of opportunities with Vietnam, and I very much look forward to achieving something there.
Yeah,
Yes,
I could say that you okay. We had the chance to visit Vietnam, and we have the I also organized some international event like the
great.
international conference. So at a time we have the contact, and I will give our maybe the chance to meet together next time. Thank you.
Yes, yes, that would be excellent. And of
Yeah,
course,
thank you.
it would be great if we could have more people working together, because obviously to achieve something significant, we need experts from different areas.
Yeah, it would be nice. Thank you.
Yes, so thank you all and have a good afternoon. So we'll keep in touch, and please feel free to reach out. Thank you.
Okay, so thank you very much, everybody, for your attendance and participation. This has been a wonderful conference, and I believe you enjoy the talks and speeches in this during this event. So, like we are open for research collaboration or like university collaborations. If you have anything, any questions or any ideas, you can write to us, and we will be here. So, like this year, we have this conference online, but we hope that we'll have in-person conference and offline conference next year. So we hope to see you on our campus next year. Until then, please take care and see you soon.
Yes, and keep in touch.
Yeah.
Thank you. Bye.
Bye-bye.
Bye for
Okay,
now.
thank you.
Thank you.
Keep in touch. Thank you. Bye bye. Thank you.
Bye.
Bye.